Okay, so again, I'm Mark Anderson. A lot of you may know me from presentations in the past, or we've met along the way, but usually I'm talking about design of experiments for chemical processes, pharmaceutical, other types of manufacturing, people that are working in R&D that are scientists and engineers. However, today I'm going to kind of go off into a different direction and talk about non-manufacturing applications. Now, although I'm a professional chemical engineer and I'm a certified quality engineer, mainly working in manufacturing, I also have an MBA. So I've always been interested in applying the quality tools for non-manufacturing, such as paperwork processing. And I worked quite a bit in a quality improvement program that did encompass non-manufacturing type of functions like accounting and personnel, travel department, and things like that. And it turns out that these non-manufacturing areas oftentimes have processes that we can focus on, and we can do charts to see, what's happening once you develop some measurements. And you can even possibly do some experiments to try to make that process more efficient and more effective. Interestingly enough, as I was preparing for this presentation, I was asked to be a peer reviewer for a very far off from normal application for DOE, which is applying it to the performance level of a curling sport team. And this is something that was submitted to the International Journal of Quality and Reliability Management. And that was, especially interesting to me because in the prior Olympics, it was a team from Duluth, Minnesota and Superior, Wisconsin from the US that won the curling gold medal. Unfortunately, this year, they didn't do quite so well. And this particular application of DOE was from a club in Germany who didn't quite make it to the Olympics. But nevertheless, you can imagine, all the different variables that would affect trying to get this stone on target, and how it might be possible to try some different things, some different types of equipment for sweeping, different techniques for the throwing of the stone, and things like that. So naturally, any type of process, should be amenable to doing a multi-factor type of DOE. So that's my topic for today. I've got you on mute because there's such an audience that comes into these tech webinars that it's hard to open up the floor to take questions during the presentation. But afterwards, we'll open up the mic and I can take some questions then. If you type in some chat along the way, I'll open that up, possibly during my presentation, but certainly at the end. And then if you have further questions, please do come back to me via mark@staties.com with those questions, and I'd love to hear from you. By the way, the presentation that I'm giving has been posted, or will be, in the form of the slides from the PowerPoint, and then there'll be a recording of this webinar, hopefully, that'll also be posted and actually will be on our YouTube channel for Staties. So if you're with me so far, not to make any assumptions that you are, go ahead and press that raise hand button again. And so I'll be asking you to do that from time to time. And there's Dave Nicolaides, I see, and a bunch of other people. So again, thank you for participating and being, active in responding. So this is kind of an ongoing project, and I'll certainly be interested to hear if you have some applications that you've worked on that are not the traditional manufacturing. So as far as talking points are concerned, then the main thing is that although these multi-factor DOE tools are very well known and proven for helping to improve quality of manufactured products and processes, they remain, vastly underutilized in terms of service, business administration, and other what we oftentimes refer to as transactional processes in my work with Six Sigma. And quite a bit of work with Six Sigma, working as a trainer twice a year for Ohio State's Fisher College of Business and their black belt training programs and so forth. And so, this again has been kind of an ongoing quest. I've worked quite a bit with Jiju Antony, who's also kind of, focused on these design of experiments in the service industry, and actually co-authored some papers and given some presentations with him and some of his colleagues. He felt, after doing some studying for TQM Journal, that probably over 40% of professionals that are actually aimed at process improvement in the service sectors really do not have any hands-on experience with DOE. So let's see if we can do something about that, because it's kind of a shame. They should at least, be aware of it and try some things. That's my opinion. So to try to prime that pump and provide inspiration, this presentation lays out several successful DOEs that I've been exposed to or worked on myself, and then just kind of talk about potential applications in many other areas. And then hopefully this will break through the current silo of DOE only being done in manufacturing and go over to the other silo of non-manufacturing. So here we are capturing DOE in one area of process improvement, and why not get over to this other side, this other silo, and apply that tool there as well. Okay, so it turns out that I gave this same presentation not too long ago to a group with the International Six Sigma professionals, and in preparation for that, I listened to a webinar by this fellow Kevin Keller on non-traditional applications of Lean Six Sigma methodology. And from his presentation, I could see that it seemed that there would be good applications in supply chain management, which is a current topic of interest, which is really logistics, human resources, procurement, finance, legal, sales, and marketing. All these areas, Kevin in his practicing of Six Sigma has, done some work. And so we know that these quantitative tools that Six Sigma applies, do have potential in these non-manufacturing areas. And then, I just did a lot of internet surfing and looked at other areas that Six Sigma professionals have worked on because of their quantitative, bent. And I also came up with, applications in healthcare, restaurants, accommodations, for example, hotels, public transportation, retail, and other service industries. Now, in regard to hotels, way back when I was traveling as an engineer to do process improvement at our plant locations for Henkel of Dusseldorf, which bought General Mills Chemical, my starting company, and I traveled around the U.S. Working with manufacturing operations to improve using statistical process control primarily, but also to some degree design of experiments. I went to stay at a Marriott hotel, and I walked in and they said, we're going to have you look at a whole series of rooms and do a rating on a scale of 1 to 10 of how you like it. And I went through and I went to 8 different rooms, and each room was set up a little bit differently. And it turned out that it was a 2-level design with 3 factors, and they had actually set up 8 different rooms in different ways. And this was way back in the day before they specialized with the Courtyard hotels and all the different types of different hotels that they had. And so I actually participated in a non-manufacturing DOE. So I know that it can be done and that people have used this technique to try to improve, their process or product. Really, any processes which are often transactional in nature that do not involve the manufacturing of goods, the things or stuff, could be subject of a design of experiments. And there's really too many to enumerate, it's just all over the place. And every day we all encounter these situations where there's some kind of a process, and we probably could do some work to improve that in a more methodical way. So if you're with me on this, that this in theory should work, and actually has been done in practice to some degree, again, press that raise hand button to indicate that you're open-minded about this at the very least, and perhaps you've even done some work on design of experiments in non-manufacturing. So, okay, so I'm getting enough of a feedback here that I don't think I'm on the wrong track. I know I'm not on the wrong track, but I'm just trying to convince some people that they ought to get on the track, and that is that design of experiments really can work on any process. It's really a blank slate. So normally what I would be doing as a chemical engineer is I'd be working on an actual reaction, and it would be something that we call a unit operation, and it would be some kind of physical process. For example, I did quite a bit of work on vitamin E crystallization, trying to improve various outputs, which were primarily the yield of the crystallization and the purity of the vitamins that were produced. However, we can think about any type of a process, and it happens that I'm on the road right now, and I went down for my breakfast this morning and they had no coffee. So, I'm thinking in terms of, for example, just kind of, brainstorming here a little bit. We've got a free breakfast here at this hotel that I'm at, which happens to be a Hyatt, and so this process needs to run well to try to get good reviews from the customers and a good experience and that type of thing. So what are the inputs here? We could begin to brainstorm on that, and that is, well, one of the main things is keeping the coffee urns full and things like that. So what do I think is my take home from this breakfast? Well, are the eggs warm? Is there coffee in the urn? Plenty of napkins, and what about the service from the servers at some of the locations as I'm traveling back from my winter home to my summer home, from Florida to Minnesota, and staying at different hotels and kind of assessing the quality of them. I notice at some of the breakfasts, the servers are extremely outgoing and friendly, and they say, welcome to our breakfast and that type of thing. Today's experience has not been quite so good. And so, maybe there's some improvement that could be made. So really then it's a matter of identifying what it is that you're working on and being, really clear on drawing that box and defining what that process is, defining, what you're going to measure that would quantify the output, and then beginning to consider what are inputs that we could control, and then doing some kind of a series of tests and making purposeful changes, not just collecting data at, happenstance, but doing a planned experiment and then using statistics to identify, what's actually significant as a filter. So these are fundamental, and there's no reason why this couldn't jump over from manufacturing to non-manufacturing. It's just that it doesn't come quite so easily to the type of people that are working on, let's say a hotel breakfast process, as it would be for an engineer like myself working in a chemical plant. But that's really no excuse. So, of course, there's a lot of challenges. As I say, part of it just the mindset of people that are working on these manufacturing processes. They just don't have the right mathematical, affinity that an engineer naturally would have, perhaps. But one of the biggest problems, of course, is that people are involved as subjects, and they cannot be easily manipulated. And oftentimes, it's difficult to choose them at random, which is fundamental for the gold standard of a double-blind test protocol. And then on the other side of it, the people administering the test are not blind to what they're doing. They know that they're giving the person, a placebo or not a placebo, that type of thing. But hopefully you can overcome that for certain situations. For example, I talked to an IRS process improvement person, which was a little bit scary. I'm not sure I really wanted to help them. And they had these different, processing centers, and there was all kinds of things that could be done in terms of changing the lighting, changing the layout and things like that. So even though people are involved, I don't think that's an excuse, not to consider doing a planned experiment. I also, as I mentioned, see oftentimes a lack of understanding or appreciation for the natural variability of a process, dealing, with calculations of standard deviation and things like that. And for example, I was doing this paper helicopter experiment at the Six Sigma training at Fisher College of Business one time. And this accountant came over to me and he said, look, I've got to talk to you in private because I have a big concern over what's happening with our results that our team are producing with these helicopters. He said, the thing is that we make the same helicopter, with the same wing length, same body length. We do everything exactly the same and we drop it and the result doesn't come out exactly the same. I said, really? I mean, that's pretty shocking. Are you mean to say that when you drop a helicopter that's been remade to the same specifications, that it doesn't perform exactly the same as it did before? And he said, yes, that's my problem. And so you can see that an accountant, expects that the numbers are going to add up the same every single time. They're just not thinking in terms of variability. Well, luckily, and this is the main reason we did this hands-on training, to understand that results do vary. And so, even in accounting, as I learned to my chagrin with monthly variances, there were all kinds of reasons why from month to month, the variance might go positive or negative for absolutely no reason whatsoever that we could determine. It was just random. So lack of understanding is another issue to deal with in terms of translating DOE to non-manufacturing. And then another one that's not unique to non-manufacturing that I come across all the time is that domain experts generally resist doing some kind of empirical study. And in my case, I've worked a lot with organic chemists that have PhDs, and they just don't like to be forced into some kind of experiment that is contending with variability because they feel like they can do everything exactly the same. And certainly when we worked in R&D in the ivory tower of research, they could control, quite a bit in terms of the purity of the reagents, the temperature control, the carefulness that they applied to procedures and things like that. But when we went out to the plant locations and they were open to the air, they had, lesser trained operators and things like that, it was a whole new ballgame. But the same thing occurs with the non-manufacturing. And you get, the marketing experts that don't want to do a marketing experiment or that type of thing because, they feel like they already know what the answers are and they just have to do one or two confirmations and that's that. So those are excuses really why it's a challenge to do DOE and non-manufacturing. But nonetheless, those seeking process improvement really must consider deploying DOE. Yes, do you agree? I'm putting the hands down now and put them back up again if you agree that we shouldn't let these excuses stop us. Good, good, good. Okay. All right. So let's continue on. So by far, the most common thing that I've seen for application of DOE is in sales and marketing. And of course, there, it's really important to improve the conversion rate, ultimately in terms of from the starting selling proposition to the final sale to see if we can get more prospects converted over. But with the advent of internet and the use of websites to try to gather interest, of course, you can measure how many people click on the ad and how many people, respond to it. So there's a tremendous amount of capability for marketing nowadays with the advent of the internet. And really, this is kind of the secret sauce that internet sellers such as Amazon have been applying. And for example, I heard that term secret sauce come in from somebody who was working with their programmers at Microsoft and gave a talk at a statistical conference. And they revealed that they were using designed experiments, but they were unwilling to say exactly how, but that they were able to get, the coding of the programming improved, and it was a vast, step forward, through whatever it was that they did, that they manipulated and measured. We don't know what that is because they don't want to say, it's confidential. Another example here that was presented by this guy, Tom Key, in his book Experimentation Works and the Surprising Power of Business Experiments, was that tests at Microsoft revealed that a tiny adjustment in the way their search engine displayed ad headlines resulted in a 12% increase in revenue, which translated into an extra 100 million annually. So we know that this can work and people are using it. They just don't like to talk about it much. In terms of selling at a retail store, I've met on a couple of occasions with analysts from Best Buy, which is based in Minneapolis. And I know for a fact that they use multi-factor testing on things like point of purchase optimization and many other types of advertising and promotion. Circuit City used what they called multivariable testing, and this was published in 1996 by Forbes magazine. And the funny thing was that this article Forbes put out about multivariable testing said that if you want to have a program that will do this multivariable testing, contact Staddy's in Minneapolis. So I started getting calls and they said, we hear that you have a program that can do multivariable testing. I said, yeah, that's right, because I was thinking in terms of something called design of experiments, and I hadn't heard that term multivariable testing. And that was when I began to refer to DOE as multi-factor testing, to be a little bit more specific, because that's really the key, isn't it? Is not just doing one factor at a time, but doing multiple factors. So Circuit City was using placket Vermin designs, which I don't happen to like very much, because as George Box said when I attended the 1996 presentation, doing a resolution 3 like a placket Berman is like kicking the TV to make it work. And Circuit City did get some improvements, but they went out of business eventually. So I don't know if that was such a good long-term strategy. Sadly, most of the experimentation that I've seen, including what's mentioned in this book by Tom Key, is simple A/B splits. That is simple comparative experiments, just looking at one thing versus another. And they are our tools, and we've seen this and used it in our marketing by email in MailChimp, but again, it's restricted to just doing one single comparison of one thing versus another, like one font size versus another font size, or one color versus another. And oftentimes it's a combination of things that makes a difference. Like maybe if you change the font and the color, you would see a breakthrough in terms of the click rate. So those are some of the applications. I don't know, I'll just took a quick survey here. Out of the group that we have here, have any of you been involved or seen DOE applied to sales and marketing? Okay, some number of people are raising their hand. So that's not surprising because it's such a natural. But once we get out of the sales and marketing, and particularly the internet website type of stuff, it gets a little bit more difficult. But here's an example of what I was saying, that oftentimes it could be a multi-factor situation. You're going to lose out if you just do an A/B split. And this is from a presentation in Essentials of Business Analytics that's referenced here. So the marketing analyst did a replicated full 2-level factorial design. They had 3 factors, so this would be another one of these 2-level designs with 3 factors, which is kind of a fundamental 2-level design. And when they looked at the results, they found that the key turned out to be a combination of going to a more modern font with a more compelling button. There was a 3rd factor, which was background being white versus blue, that did not create a significant effect, but yet that provided valuable insights as well on the drivers for conversion. And you can see here the fundamental aspect of an interaction, that the effect of one thing, which is the font type, going from classic to modern, depends on the other thing, which is whether the button says OK or whether it says click now. So what we see is that there's a main effect that's compelling in terms of switching from the OK to the click now button. But also, once you're at the click now, when you switch to the modern font, then you get a further increase, and this is the breakthrough improvement up here that creates a huge increase in conversion. So seeing how things interact is oftentimes the key, and it's important when you do your experimentation to do a multi-factor type of experiment, because one factor at a time will never reveal interactions like this. So moving on from sales and marketing into some other areas, I've got a couple of examples on making training more effective by using designed experiments. Now, the first example I have is a bad one, but it's no reflection on Chris Knoxheim or Brad Jones, who were just trying to prime the pump a little bit with this article on DOE and Six Sigma, getting to the root cause in the Six Sigma Forum magazine, because they didn't have a whole lot to work with here, but they put out an example of a simple comparative DOE, which is like an A-B split, better than nothing, that was done on a team of programmers at a large insurance company. All the programmers were offered a workshop on a new coding tool. I think it was object-oriented programming, and half accepted, and then they were rated by their managers. Now, you're beginning to probably shake your heads at this point, because we have some major flaws here in this experiment, which Knoxheim and Jones are just reporting on. They didn't design it themselves. But it was just a single factor for one thing, which is not good. It was self-selection of the subjects, not randomly selected. And then the evaluators were not blinded, and nor were the actual volunteers as well, because you would know you had training or not. So in the end, then, we have to take this with a huge grain of salt, but at least it's on the right track. And this happens to be, from an old version of JUMP, I think. And you see that these LSD bars are presented by the program. And we see that when they didn't take the programming training, they were rated, much lower than when they did take the training. Now, whether this is really an actual thing that would be confirmed, you'd have to do a proper experiment, by doing the correct, random selection, etc. But nevertheless, at least it gives you some idea that this ought to be something we can do. We can apply DOE to training for sure. Let's just do it, a little bit more correctly in terms of the selections. Now, another one that relates to training I came across in some research I did for my training at Ohio State Fisher College of Business. And this was from this Lean Six Sigma Summit in 2005. And this company, Mannington Mills, had a team of Six Sigma black belts working on trying to improve this filling out form process. So they did some brainstorming, and you can see one of the key factors is whether they trained the people filling out the form or not. The size of the customer, which I suppose changes the number of items on the form. The type of customer, this is a categorical factor, retail versus consumer, and then a numerical factor is the number of items on the form. And I don't recall what type of experiment they did. They might have done a 2 to the 4 minus 1, which would be a half fraction. That would be a resolution 4 design that would at least give you a good idea of main effects. And then they had a number of outputs, but the one that they reported was the completeness. And they were currently averaging 50% defect. So that when you're averaging that great of a defect, it doesn't take very long and doesn't take a big subgroup to see if you've made an improvement. So over here, you can see the results. So I've got this listed as a 2 to the 3 full factorial with only 3 of the items that I had on that process flow chart that I showed on the prior slide. So here we have at least a subset of the things that they tested laid out in a full factorial in standard order, from low to high in the first column, 2 lows and 2 highs. And hopefully they did this in random order, because you don't want to have a plan for experimentation that changes one factor all at one level and then all at the other, right? So you want that to be in a random plan. So here we're measuring defect rate. So I would imagine they filled out, 20 forms or something, and then they measured how many of them had, at least one thing wrong with it. This would be an example where maybe counts of imperfections would have been better, but they were able to get a big enough contrast on the results here that it ended up that they were able to see, and this is an output from Design Expert on a half normal plot, that two main effects stood out, whether you had more or less items in the training. And so I made a little tower chart here, and you can see that if they have many items and they have no training, the fraction defect is, even above 0.5. But if you do the training, yes, and you're working with fewer items, then you can get that defect rate down. So that gives you some indication that this is possible. Okay, so does that look promising? Yes? Hands? Okay. Thanks. I got 2 Allens from the start at the very top of the list, so it's in alphabetical order by your first name. So I'll take the 2 Allens as my canaries in the coal mine that I'm on the right track and you guys are able to follow me on this. So now let's talk about another application, improving delivery time. And this is, I'm kind of shooting around to different, non-manufacturing areas here. There's no comprehensiveness to this, it's just kind of a scatter shot. But I happen to be looking back through my hardcover from Montgomery, Design and Analysis of Experiments, 8th edition. And I knew from having worked with Doug over the years that he had done quite a bit of work, I think when he was working at Georgia Tech, and maybe it was with Coca-Cola, I'm not sure. I don't know the provenance of this, but he had done quite a bit of work in non-manufacturing areas. And his background as an industrial engineer kind of led him to this. So he worked with this industrial engineer, maybe it was him that did the work, and they asked 2 workers to move 40 cases of glass versus plastic 32-ounce bottles 50 feet on a standard hand truck and stack them onto a display. And then they required that they do this 4 times over. Wow, that's a lot of work, but it's pretty impressive that they were able to, talk these people into doing this amount of work to try to learn more about how they might be able to improve this process. So we have this table, and there's actually 2 different workers, 2 different bottle types down here. And then this is the time on the left side. And on the right side is the pulse rate before and after. So this is the increase in pulse rate, which is a bit alarming. So I took this data and I entered it into the Stati software. I'm using Design Expert, but it would work out just as well to use the new Stati 360, which is a superset of Design Expert that incorporates all of the Design Expert features plus some additional things. But I'll just go to Design Expert on this one, and let's see what I've got here. Track down this file. So here is the data in standard order. And I'm just going to pop open my window here and just check and see, do you all see the design layout here on Design Expert? Yeah. Okay, I'm looking down through the list. Alan, I'm going all the way from Alan to Wayne on this one, so that gives me a good sampling. So then over here are the data, and normally what I would suggest once you've designed this experiment and collected the data, that you would just do some sorting of the responses to see how much they range. So I'm looking at the time. This is in hours, so it took them quite a long time to move all those bottles, all the way across and stack them back up again. And then the pulse rate, that really does look, impressive, from going from 10 elevated pulse to 58. So then normally what I would do is use our program to just do some simple scatter plots on the time response as a function of bottle, which is categoric between glass and plastic, and the worker between 1 and 2, and then the pulse increase from one worker to the other. And it looks like there's some fairly dramatic differences here. So let's see what happens when we do the effect calculations. Okay, so here's the first one. Now, because it's been replicated so many times, we get the measure of pure error being superimposed on this half normal plot with these green triangles. And we do see the main effects of the bottle and worker standing off to the right, but also possibly this interaction of the bottle and the worker. Let's look at the Pareto chart. The AB interaction doesn't quite make it to this t-value limit, but I went ahead and put it in anyways. And it does turn out that that AB interaction doesn't come out significant at 0.05, but I'll leave it in there just for argument's sake. Nothing abnormal in the residual diagnostics. And of course, because this interaction isn't probably significant, these two lines are almost parallel. So the effect of changing from glass to plastic, which of course would reduce the time because it must be quite a bit lighter, is one effect. And then going from the red to the green line is going from worker number 1 to worker number 2. Worker number 1 is obviously more efficient than worker number 2. So that's the outcome for the time. And then for the pulse increase, I guess not surprisingly, when I look at the difference in workers, one of the workers stood out, as having a much bigger impact on the pulse rate. And let's see what that was. Okay, so worker number 1 had a much greater elevation of pulse rate trying to do all this work than worker number 2. So I just have an imagination of worker number 2 being somebody who's quite muscular and, quite fit, and worker number 1 is not able to keep up with worker number 2. So this is kind of an interesting non-manufacturing output. And then just to kind of put icing on the cake, I noticed when I did my diagnostics, and I looked at the main diagnostics I like to study, which are the normal plot of residuals, which should follow a pencil test. They should all fall under a pencil, and maybe we'd have to move to a fat pencil, but that still wouldn't work. And then we look at residual versus run for potential outliers. But then what's really interesting is the Box-Cox plot is saying, well, we really need to take a log transformation. So I just refined this a little bit, taking a log of the results. It still shows worker as the only thing that's affecting the pulse rate, but then we get a slightly different outcome here. Notice the least significant difference bar shows more of a variation in pulse rate for worker 1 because their elevation is much higher than we see for worker 2. Their pulse rate is not changing as much, as worker number 1. So that I thought was a pretty interesting application of DOE to non-manufacturing that's, out of the Montgomery book. And it relates to, kind of logistics type of situation, like a supply chain type situation. But again, it's a process. And so, it's repetitive. There's factors, there's things we can measure. So why not? So then all I've got at the end here is just a list of a bunch of other applications. And it turns out that when you get to the posting of the slides, you'll be able to open up this link here that goes to a more comprehensive list that I've developed called DOE for non-manufacturing that's posted to the Staddy's website. So make a note when you're done with my presentation to go back, find the slides when they get posted, and pull this up if you're interested. And I've got references that connect up to, a number of different applications for non-manufacturing. Now, what I've got listed here are just some fun ones that I picked out of this document. And one of them I worked on with a candy maker out of Chicago called Brock. And their sensory expert had somehow heard about using design of experiments, and in particular mixture design, And they said, well, what do you think about considering a box full of chocolate covered cherries as a mixture? And Pat Whitcomb and myself, who were operating Staddies at the time, thought that ought to work. And we also asked if they would send us some samples of the chocolate covered cherries, which they did. So this was one of the funnest design of experiments we ever got involved with. And it turned out that they were looking at what might happen if they had a right side up chocolate cherry as one component. This was a mixture design, so the cherry could be in the box right side up, or you could have a certain proportion of the cherries in the box leaking, and some of them could be upside down. And so this formed a little mixture design. I think they were, not able to put too many leakers in or upside down type, the upside down cherries, but they certainly couldn't put too many leaker cherries in. So they were restricted to some region. I forget the details of it. But what was interesting at the end, when they looked at the sensory in terms of whether it was acceptable or not, they turned out that people actually liked having one or two cherries upside down or even sideways. They didn't like the leakers. But what happens is you get a box full of chocolate covered cherries and you look at it, and if there's one that's upside down, if you're like me and you're kind of a little bit obsessive compulsive, you end up grabbing that one that's upside down and eating that right away, which is very tasty. So that actually was a ploy that they could use to make their chocolate covered cherries more enticing, is just throw one of those cherries upside down, but make sure it doesn't leak. So that was a pretty interesting one. Then getting into more mundane applications, billing. When I went to the George Box seminar in 1996, there was a statistician from Southwest Bell, and they were working on their billing and trying to make the billing more comprehensive to the end users. That back then they would mail them out, and so I know that they used DOE for that purpose. And I think this may relate to it in terms of the factors that were studied. But I've seen at least, a couple of different applications of DOE to billing processes. Medical services, I think, is a huge area. When I was doing my teaching at Ohio State, we had a lot of hospital administrators that were going for their Six Sigma Black Belt. And there's a lot of aspects in terms of medical services, training of patients, processing of patients into the hospital, and things like that. And this was a good one because they help people learn how to safely take warfarin, which, as you probably know, is a very powerful anti-blood clotting drug. Air traffic control, I came across somehow that FAA did some investigation of a simulation model for the New York air traffic control. And by the way, nowadays, I'm going to recommend Staddies 360. If you're working on a simulation and doing a DOE against a simulation, Staddies 360 has some really good tools for what are called computer experiments. So in Staddies 360, we've got space filling designs, Latin hypercube designs, and we also have Gaussian process modeling as a tool. So just a heads up, if any of you ever get involved in a simulation model. Sales, we talked about, the sales and marketing. This one was actually on a group of people in a team that were trying different attire, whether they would go formal or casual, and whether they'd send one salesperson in or two, and then whether they did a high pressure sale or low pressure and use their older brochure or a new brochure. I think the obvious answer is they should use a new brochure. And I hope that they don't do high pressure. I don't want to be subjected to that myself, but they did look at those factors and they were able to work out how to sell more products. So I guess it was a success. Information systems, if you're involved in IT, there might be some things that you can do. This is an example of a major telecommunications provider, and they did a series of different DOEs, and they were able to reduce outages minimize order processing, etc. And then sports, as I noted at the outset, the curling team that did their experiments at this German club, and they were able to improve the accuracy and precision of their throws. I did a little experiment when I worked at General Mills Chemical Research, and I was on the softball team. And I was, pretty good back then at running around the outfield or the infield or wherever they might need me. So we had a 10-person team in softball. They have one more than the normal baseball. And that 10th person is kind of like the fifth wheel, and you're never quite sure where to put the 10th person. Should they play short field or long field? In other words, 4 across or come in. So I said, let's do a randomized experiment. And depending on the randomization plan, any given inning, I said, I'm going to go out deep and play the whole inning, and we'll count how many bases that the other team gets. And then maybe the next inning at random, it would say, I'm going to go short. And I'd move in short and run around short and count how many bases. Well, most of the guys on the team liked that idea because they were researchers and they believed in DOE. But we had one person that didn't work for General Mills Chemical Research, who was a pharmacist, and he got really mad because he said, Mark is out there and we're losing the game because they're hitting the ball in front of him when he's playing deep. And when he plays short, they hit it over his head. And so we're losing. And so we got to quit this experiment. But all of us said, no, we have to continue this process even though we're losing, because we're going to learn something. So at the end, we determined that it was better, I forget which way, if I played deep or short. There was a statistical advantage to it. So the next year, I just did the same position the whole year, and we won the championship. So that was kind of a cool story in sports that I was involved with and actually designed the experiment. And it kind of illustrates in the short haul how, if you're trying to manufacture or run a process, doing the experiment might interfere with the quality of that. But over the long haul, if you're willing to absorb some expense, you're going to win out. So that's all I have. And I just want to finish up with this quote from Juju Anthony. It's kind of long, but I thought it was worth passing along because it's really important to do better at applying design of experiments in non-manufacturing and in the service industry in particular. And he said that there's some problems here. One of the biggest concerns is that the senior managers feel like DOE is too technical and that it can't work in their area because of it dealing with people instead of machines. So what Anthony proposed is that senior managers in the service industries should be introduced to DOE, and that would be where you guys who are listening to this presentation come into play. And the same thing I appealed to the Six Sigma audience when I gave this talk to ISSP, that we need to approach these managers and educate them that DOE is a multi-factor tool that can be used to improve, all these different attributes that they're trying to get better. Ultimately, the greater sales. And then if any of you do apply DOE to non-manufacturing, will you please publish your results and lay it out so that it provides inspiration for others? I'd appeal to you for that in this small community that we have, which are you guys, to get out of the silo of manufacturing into the silo of non-manufacturing if you can, and look for an opportunity to apply these multi-factor tools. So hopefully, as a result of this presentation, you have some take-homes of that multi-factor tools can be applied outside of the manufacturing into the non-manufacturing, whether it's service, business administration, or whatever transactional process that you're working on. And to do that, inspiration, I presented several successful DOEs, just a few that I happen to, literally cherry pick out in the case of the chocolate covered ones. And hopefully this will provide inspiration for you and for people that you work with to get out of the current silo of manufacturing, with DOE and get out there to the non-manufacturing. So if people have an interest in this, I would recommend this book over here, the DOE Simplified, which is now in 3rd edition. That's become kind of a go-to for Six Sigma training because it's kind of simple and fun, but introduces multi-factor type testing. So that would be a good book, I think, to use if you're doing training for non-manufacturing, Six Sigma. And then possibly you might want to see a way clear to sending some people if they're really getting into Six Sigma up to the level of black belt to this modern DOE for process optimization. That's a distance-based presentation over a period of 5 days each morning, Monday through Friday, and you really become an expert at the end of that. So with that, I'd like to conclude my presentation and, thank you again for sitting in on this. And at this point, I'm just going to open up the microphones. If anybody wants to jump in with a question, have at it.